Alright, the last topic in this section is on similar triangles. It's section 6.6 in your textbook. We are skipping section 6.5. It's not a part of this course anymore. So section 6.6 is on what we call similar triangles. Two triangles are called similar if two conditions are met. The first condition is that all the angles are, I'm going to say matching, which we don't really focus on the angles for this class, but if all the angles, did I spell that right? If all the angles are matching, then the triangles are similar, and if the sides are proportional, the triangles are called similar. And the symbol for similar is a single squiggly line. Single squiggly line is the symbol for similar. So if the angles are matching and the sides are proportional, the triangles are what we call similar. And it helps for this to have three different color pens or markers or colored pencils, to have three different colors to help with this. So it's a little weird at first, but it's, again, relatively straightforward. So example 1 says, find the missing sides of the triangle given that triangle DEF is similar to triangle ACB. So DEF is the little triangle, ACB is the big triangle. And the way this works out, if they're similar, then side DE is proportional to side AC. And it will say that by the order they list the letters. DE and AC are both the first two letters in the triangle name. So that means that those two sides are similar to each other. They're proportional to each other. And if we switch colors, the second two letters, EF and CB, those sides are proportional to each other. EF and CB. EF and CB, hopefully you can see that, are proportional. And that means that the last side, this little side DF and AB are similar to each other. So if you have three different color pens or pencils or markers or highlighters, you want to mark the proportional sides in the same color. And if you're not sure, use the letters. The order of the letters will tell you the proportional sides. So from here, we're going to solve for the missing sides. You see 5 meters on this little side and 15 meters on the proportional side. The purple side, EF, is missing anything. I'm going to put an X there to help us set up the proportion. And X is proportional to 33, and then Y is proportional to 24. So each side is proportional, which means I can set up a proportion to find the missing sides. So I know that 5 is to 15 as X is to 33. So I have to be consistent. If I start with the left side triangle, 5 to 15, I have to be consistent X to 33. So if I go left to right, I have to go left to right. So you have to, again, be consistent with your setup. And from there, I can cross multiply and solve for this missing side X. So I can cross multiply. 15X equals 5 times 33, which is 165. And then divide by 15, and that can give me the missing side X, which is 11, and it's being measured in meters. So I just figured out that the small side here is 11 meters because they're proportional to the pink side. I can do a very similar setup to find side Y, again using the side that they give us, 5 and 15. So 5 is to 15 as, and since I went left to right, I have to go left to right. Y is to 24. So now I'm going to solve for the bottom side, the blue side. And again, I'm going to cross multiply to find the missing side. So 15 times y equals 5 times 24, which is 120. Divide by 15. And the missing side y is 8 meters. So this little side is 8 meters. So I can set up a proportion to solve for x and solve for x, proportion to solve for y and solve for y. And I'm using the same ratio, 5/15, because those are the matching sides that they gave us. So again, as long as you're consistent, either left to right or small to large, however you set it up for the first ratio, you have to be consistent in the way you set it up for the second ratio. Let's try that again. Again, have 3 colors that are distinct so you can see the difference between the sides. So example 2 says find the missing sides of the triangle given that triangle ABC is similar to PQR. And these triangles are kind of turned around and flipped. It's hard to tell which sides are proportional. So AB is proportional to PQ. AB is proportional to PQ. It's a little hard to tell because these are kind of turned around. So we color code to help ourselves out. And we use the letter order to help. That means that BC, the last 2 letters, are proportional to QR. So here's QR and here's BC. So color coding can really, really help here. And then the last side, AC, is proportional to the last side over here, PR. So if you can color code, it helps you line up your proportions. And again, we're going to set up 2 separate proportions, one to solve for x and one to solve for y. So I'm going to start, it doesn't matter which one, I'll solve for x first. The matching sides I have are 7 and 14. I tend to always go left to right to be consistent. So if I say 14 to 7, I have to be consistent. That would be 10 to x. So left to right, left to right. And you always set up your matching sides. So 14 is to 7, as 10 is to x. And you start left to right, left to right. You can also go small to big. As long as you're consistent, it doesn't matter. But when you set up your proportion, we cross multiply 7 times 10 and 14 times x. And that's 70 equals 14x. Divide by 14. And x equals 5. And this time it's being measured in feet. So this side we just figured out is 5 feet. And then again, same ratio. I'm going to be consistent here. 14 to 7 equals y over, where's the blue side? 3. So I did left to right, left to right. So always consistent in your setup. And then we'll cross multiply and solve for y. 7 times y equals 14 times 3, which is 42. Divide by 7, divide by 7, and y equals 6 feet. Some of you might have noticed a pattern like 14 divided by 2 is 7, so you can use that to help you solve, but it's not always a pretty number. So again, setting up these proportions and cross multiplying is the most consistent way to always get your answer. So the x side is 5 feet and the y side is 6 feet. 2 separate proportions using the ratio that they give you. And color coding is very, very powerful here. Alright, if you're feeling pretty good, you can pause the video and try example 3 and maybe example 4 also. If not, we can keep going. It's the same idea, just color coding really helps. So example 3, find the missing sides of the triangles, given that triangle ABC is similar to triangle PQR. So I have my 3 colors. And when I'm not sure, I start with the first two letters, A, B, and they must be similar to the first two letters here, P, Q. So side AB is proportional to side PQ. And then the second two letters, BC, are proportional to QR. So here's BC, and here's QR. And that leaves the last side, AC, is proportional to PR. So again, color coding is very powerful here. Now we use the one set of sides that they give us and set up two separate proportions. We're going to solve for x first. So I have the pink side, 10 over 30. This time I'm going top to bottom, equals x is on top over 18 on the bottom. So 10 is to 30 as x is to 18. So keep consistent. If you want big to small, that's fine. Small to big, that's fine. Just be consistent in your setup. And then we will cross multiply to solve for x. 30x equals 10 times 18 is 180. Divide by 30. And x equals 6 meters. Same idea to solve for y. We're going to use the ratio they give us. 10 is to 30 as, and since I went top to bottom, I have to be consistent here. 8 is to y. So top to bottom, top to bottom. And then cross multiply. 30 times 8 is 240 equals 10 times y, which is 10y. I shouldn't have put the meters on there, sorry. That's distracting. And then divide by 10, and you should get y equals 24 meters. So that gives you the missing side lengths, 24 meters. So x is 6 and y is 24. You usually have two missing pieces on the similar triangle problems. Alright, and then here's a word problem, but again, it's not so scary because it's just a proportion. It says a flagpole casts a shadow 99 meters long at the same time that a pole 10 meters tall casts a shadow 18 meters long. Find the height of the flagpole. This is a very common proportion problem. So the shadows are going to be similar at the same time of day. Shadow lengths are going to be similar, which makes the height of the pole similar to the height of the flag, and they've called the height h, so we're going to use that same letter. So my proportion will be 18 is to 99, I'm going top to bottom, as 10 is to h. So consistent setup, shadow to shadow, pole height to flag height. And I'm going to use h for the height. And then we cross multiply. 99 times 10 is 990 equals 18 times h. And then divide by 18. Divide by 18. 990 divided by 18. H equals 55 meters tall. So that's the height of the flagpole. So even on these application problems, as long as you're consistent in your setup and draw a picture to help if you need to, you'll be good to go. And that is solving application problems with proportions using what we have, similar triangles.